for electric driving. So one or the other slide I will skip now in order to have a short presentation and to end the discussion and the presentation in time. So, well, short introduction about myself, that you have an idea why I'm standing here, which was almost given. So then we will have a short look on autonomous or automated driving. We will have a short look on the topic we just had right now, greenhouse gas emissions, and then on low emission transport systems, especially propulsion systems and lightweight design and sustainable process and production processes. So I hope I will can keep this line and will make it in time. Well, I have been introduced already. Austrian Institute of Technology is the biggest non-university research institute of Austria, and we do have on our special agenda and topics of infrastructure on the research. So we do have an energy research department, we do have the mobility research department, health and environment, safety, security, and innovation systems. Well, and there is a department of mobility which I'm heading on, and well, if we look at the major research topics, that are actually to be seen in transport techniques, we have the topics on the transportation infrastructure, road, rail infrastructure, bridges, and so on. We do have to consider what are the innovations and what are the research in the transport means, so our vehicles that move us from A to B, and we do have to consider the research and innovations on the mobility systems, the management system, transport management system, transport logistics systems, and so on. So these are the major topics we are covering in our research. And just to give you an idea, well, of course, there are these very popular topics which are automated driving, which are electric cars and lightweight, but there's quite a lot of more research on transportation, but the major peaks are according to this. So these are research peaks. We used here 40,000 publications, and we're looking for the topics in this publication in scientific reviewed journals. And then you see on the infrastructure side, of course, you do have emissions, noise emission, gas emissions as a huge peak there in the landscape. But already for the infrastructure, you have ad hoc networks, so a lot to do with automated driving in future. So one of the major issues in research of infrastructure topics. If you look the scientific journals from the point of view of our vehicles, low emission transport vehicles, then you have a very strange picture. So again, here 20,000 publications covered. What is the topic here? It's electromobility, and it's battery technology almost only from this plot. So you can see different types of batteries where the research is going on. And if you look at something like I mentioned before is a big topic, lightweight materials and lightweight construction, you will find it over there in these areas, very tiny plots against the volume that is published. And this was published from 2008 to 2014, published in Battery Techniques and Electric Vehicle Techniques. So from research point of view, quite a huge amount on electric driving. Again, if you do this from the point of view transport management, well, there are several interesting peaks. And of course, you find quite huge amount again on automated driving, connecting vehicle to vehicle, connecting vehicle to infrastructure, and so on. What is also quite important, you have quite a lot of research going on transport behavior, individual transport behavior, behavior of humans and human groups is quite an important point here. And well, I will not cover each and every peak. And of course, you will find quite a big peak also on safety and traffic management system and multimodal traffic management system in this area, which you will get as a PDF to look at each individual peak I will not cover right now. Well, might be that this should be the only slide I should give for automated driving. This is not driving. This is a picture from Austrian Airlines. But if driving could be like this, yeah, I think we all would appreciate. So it will come. It will be. Usually I don't like to talk about the future because you can have a lot of foresight processes to generate scenarios, but none of the scenarios will happen. But automated driving will be reality in future, and it will come. And I think the very important point is because it's cool, yeah, to travel like this. Well, there's a lot of things going on from each and every OEM with respect to automated driving. I think, well, you all might know of several of these things from Mercedes, of course, also from Audi. They're quite good performing there and doing a lot of, let's say, public-related actions, of course, because I don't consider that it will be like this, that we have automated driving at a certain step. So it will be an iterative way, and we will not start with the Google car like it is right now, because it also runs only under several circumstances which are usually not that much transported in the newspapers. But the future will come, and we will have this technology. Well, where we are, of course, you know that there are several partial automation systems, and from parking assistance, line keeping assistance, and so on, which are already reality. So in this point of level of automations, we are steadily increasing. So we will have an iterative innovation process. What is a major barrier now is when we go to what we call a level 3 automation. Conditional automation is when we do not need to react to a certain thing that happens during driving. So the driver is out of the loop. And then we do have a quite big legal issue. And there is a law that is called the Vienna Convention, an international law, Vienna Convention, that basically says that at each and every time driving a car, we have to know what's going on. And at this step, when we go to this conditional automation, we do not know this. And I think also Audi is already jumping into this border. Also you are developing this parking assistance where you jump out of the car in front of the building, and wherever your car wants to stop, you are at this point. And then it's not only a technical issue getting to the innovations, it's here a huge legal issue. Well, skip this. Of course, there are quite important factors that we should get to autonomous driving, and the most important factor is here Vision Zero, the safety aspect. Yeah, almost all accidents that happened are because of human errors, and this is the most important point, I think, why we have to go to automated driving, and it will happen. Well, the resources, of course, also when we do have automated driving, we expect that the energy consumption and the resource consumption will decrease. But from point of view of industry, how to sell, of course, this is the important item. There will be a huge improvement in comfort. There will be something like a prestige thing again, and we have to buy and we have to think of the market not only on technical benefits, it's also the prestige that is increased. And of course, well, there is elderly people which might be able to travel by car if we do have automated driving. So this is just the thing to mention. There are a lot of things to do, and these things are going on, and we will have automated driving. if you check in the newspapers, discuss in the research forums, somebody is talking about 2020, others are talking about 2025, full automation, maybe 23. So we all don't know when we are really there. It's in a visible range. Well, but there is some general problem about our transport, and quite a lot of this topic was just covered right now. And there is the thing I would like to mention. We really have to appreciate something like this GTRON and research that is going on to make more use of intelligent use of renewable energies, because the transport sector is quite a huge sector in consuming the energy that we consume in all over the world energy processes. So I do in this circle industry process, transport process, not included are processes like deforestation, which is not covered here. So we have 27% in transport, and we have quite a huge part in industry. And we do have the steel industry, and we do have the aluminium industry, which again is producing quite a lot for transport. So this 27%, well, that's just moving. And there is the rucksack you have in front when you produce your steel, your aluminium, your carbon fiber reinforced plastics. Yeah? So I'm just use here one typical presentation, what we do expect and what especially the OEMs do expect. We will have a diversification of energy carriers. So we had a lot on discussion now on methane and CNG. Of course, biofuels will play a role, and somehow we consider to reach this 80% goal of decarbonization of our energy carriers by 2050. This is the rather actual plot of the energy distribution of Germany. Well, the tendency is a little visible here where you have the renewables. I do not like to show the picture for the worldwide trend, because there you will see the increase is just by coal, just by burning carbon, almost just. Yeah? So it's not really promising from the worldwide prospect, but from a European level, well, we see the trend is moving in a positive direction, but there's still quite a lot to do. So with this diversification of energy carriers, we do have also the diversification of powertrains using different. So this is a picture. The original source is given here, but also from the colors you have the indication. This is from an Audi presentation given 2 weeks ago in Vienna. Well, of course, we will have a diversification. We will have still in 2030, and the figures do not differ too much if you go to other sources. We will still have quite a huge amount of, let's say, conventional. It's not really conventional, but we will have conventional engines. Then we will have the hybrids. We will still increase in the hybrids. I think the reason for it was pretty good given, and we considered this is the right way of thinking. Hybrid is a quite good solution, and especially for the very short distance driving, we do have the pure battery electric vehicles and the fuel cell vehicles in future. Well, okay, so the way which the OEMs are typically moving is modularization of their cars. Modularization, by the way, to get the production still in a cheap manner so that they can easily jump from diesel, gasoline to CNG, plug-in hybrids, and to the fuel cell. Well, this is also true for other providers like here, Mercedes, but here there is just a picture given again stating, well, electric drives makes quite sense, not only from the energy point of view for short distances, but also from the pollution point of view. I have been in Japan 3 weeks ago. If you go in the city there, they have quite a lot amount of electric driving. The air pollution is really different to Europe. Yeah? So they use battery cars and CNG cars mainly. And you really see a big difference for the local pollution. This has nothing to do with the CO2 or greenhouse life cycle assessment. But there is a good reason to have electric cars in the short range. And if you go to a long range, it's hybrids and electric vehicles that should come. Also already mentioned energy consumption wheel to wheel. This is not life cycle assessment like we have seen before. So life cycle assessment would give the picture a little bit worse, especially if you go to fuel cells and the batteries. So this island, and if you do a life cycle assessment, you will find that using gasoline and diesel might be worse than using, might be better than using a battery EV if you use not renewable electric power. So there is quite a huge range for the energy consumption of a electric vehicle. So you have to have the right and proper energy mix, and in Austria we have pretty cool energy mix because we have the benefit of a lot of water energy. Well, talking about innovation, well, it's here. The hybrid cars are on the market. This is units sold by Toyota, given also a few weeks ago in a presentation by Vienna, actually on 7 million units. So they're quite in front here. And it's the same also for Toyota, playing this modal game to have their cars manufactured in a rather cheap way. And they are coming now in, I think it was April, with their fuel cell car. Myra will start commercialization in April, and at the end of the year it will be also available in US and in Europe in a small amount. I think they've scheduled 600 cars for this. Well, why is it that interesting? Just a very short look on a electric drive. This is a drive we have developed for a very small city vehicle, in-wheel drive. But what is the important thing? We have discussed before efficiency, and as soon as I can use electric machines, I have rather huge and good efficiency, like here the torque and the speed, and you always have a really huge efficiency of your machine. So as soon as you can use electricity for driving and propulsing a car, this is the best way to do it and the most efficient way to do it. Well, and of course we have to reduce the weight. Here a diagram, how much, pretty much a linear relation between the fuel consumption and the weight of the car. So of course it's a necessary part that we have to go with lightweight design. There are quite enormous research projects and innovation projects to increase the part of lightweight design also for the automotive. Here we have a comparison what is done in lightweight technology in aviation. So we have a penetration of lightweight design about 80%. In windmills, well, we have moving parts. There it is interesting to do some lightweight design, and for the rest it is not of interest, so it will stick here. For the automotive part we will get quite an more increase on lightweight design. Well, at the moment, materials which are really in discussion with lightweight design is, of course, still steel, yeah? So very high strength steel, but also aluminum alloys and carbon reinforced polymers. So there are several reasons and things to discuss on benefits and negative aspects. Well, carbon fiber reinforced polymers are more or less, from the engineering point of view, at a very early stage. So our engineers have to develop their skills to work with a material that is fully anisotropic in their behavior. And that's a major drawback of this material. And then there are quite some arguments in processing these materials for getting it on the market. So if you look what is available on the market, well, there are these fancy cars, yeah, like the KTM or the BMW, using quite a lot of carbon fiber reinforced plastics, but there are several reasons to switch from the left side to the right side, where we are more or less on the Audi side of designing a lightweight car, a lightweight aluminum space frame. And the reasons are pretty much given here, and you can read faster than I can talk about. And of course, there's also not only technical aspects, there's the unique selling point. So BMW would not go on the market with the same arguments than Audi. Okay, so at the very end, I would highlight once again on our consume of materials. And here I show a plot of embodied energy till you get to the material where you want to produce your transport vehicles of. And you see aluminium has quite a huge amount of embodied energy compared to steel. Well, and this is the reason why you still have to consider, is lightweight design always the right thing? How much is this energy worth to utilize steel aluminium in constructing our vehicles compared to steel and plastics? Well, of course, you see here now a little bit more complex map, and here we have energy per cubic meter, so the volume, the size of the car is pretty much dependent of our size. So I think it's worth to look not only on the kilogram, but also on the energy per cubic meter. And here you see, here you have the carbon fiber reinforced plastics, here you have the stainless steel, magnesium alloys, which are definitely a candidate for future lightweight alloying, and aluminum alloys are also given here, and they get more closer together. But still, we have quite a good position of steel in this diagram. Well, and why is our discussion of all these energy topics that much important? Here a plot of the historic steel output until 2009, so it's increasing pretty fast, especially in the developing countries. Here the green line for Asia, and we do have quite a stable situation in US and Europe. The same plot for aluminium, so we can consider that the energy consumption producing our raw materials, our materials for transport, is still increasing. Aluminium is increasing also in Europe and in USA. But if you look at what kind of material consumption we do have per person, we see that in the in our fully developed countries, we have quite a settled amount of material we utilize per person. Japan is pretty much different on a much higher level, but this is not transport related, this is building related. They have to build earthquake safe buildings, and this is why the peak of the Japanese is much higher. But in the developed countries, we do have quite a stable situation, but here, China, India is still on a very low level. So from this, you have prediction what might be the future, and the future for the steel consumption. So steel industry don't have to fear too much. There will be still in total a huge increase, and aluminium will be also quite a huge increase. And this is why the AMAG in Austria is investing quite a lot in their production system, and also the first in Linz is investing quite a lot, because it is visible that the consumption will be much more. And this is a rather critical outlook for the next 40 years. We will double our energy consumption and our material consumption, but have to cut off half the CO2 emissions. And this is quite a process, and one of these research part that has just been demonstrated with the GTRON project is a very important countermeasurement to this development. So also for transport, it's quite important to consider where is the energy consumed before our vehicles start to drive. And well, whatever material we are looking at, it's in processing the high temperature process here, steel making for steel, which is capturing almost the whole energy amount, and aluminium making also the main part here. And this is the one slide which looks quite complete, which I like to use to close this session. Well, we have to work from industry development quite a lot in how this material is produced and reduce this energy consumption. And we have to work a lot on reuse material, reuse scrap material, reuse yield. But there is also the design issue. Use less by design, so optimize our design, and a rather more social thing. So not only industry can keep with this problem, reduce the demand, and try to have longer life in our goods. So, well, we are a research institute, not only industry driven, so otherwise I would not mention the last two items, but and with this I want to close.